Hello and welcome to episode 3 of our series Back to Basics Business Technology Platform. After having seen the definitions, what SAP HANA has for characteristics, let's focus on the 3 other databases that SAP have. In the previous episode, you learned about the HANA platform and have been introduced to its capabilities. Now, as powerful as it can be, it is not possible to answer all the challenges induced by modern data management with this platform only. The diversity of requirements such as mobility, 24/7 availability, massive data processing, or data destructuring evidently show a reality fact. We cannot do everything with one single data technology. Even if sharing base concepts, specialized data engines will be required to cover all the needs. To take an analogy, with my personal car, I can use most of the roads, but I won't probably be able to drive on any pathways like clay tracks. Just like if I have to transport tons of material, I will probably use a truck designed for transporting heavy goods. When SAP acquired SAP ASE, we inherited 3 database technologies that were all dedicated to specific utilization of data. These are ASE, IQ, and SQLAnywhere. Let's start with ASE. ASE is short for Adaptive Server Enterprise, the relational database management software manufactured and originally sold by SAP ASE. ASE is an enterprise-class RDBMS, a relational database management system, which is especially good in handling OLTP workloads. ASE is used intensively in the financial world, banks, stock exchanges, insurance companies, in telco, in e-commerce, as well as in virtually every other area. ASE is a disk-based relational database software intended to serve business-critical applications. Prior to 1994, SAP SQL Server evolved along the same lines as Microsoft SQL Server. Then Microsoft bought a copy of the SAP SQL Server source code and began engineering its own product along a different line. A couple of years later, SAP ASE renamed its product ASE to distinguish it from the Microsoft product. On a technical note, a major advantage of SAP ASE over other database vendors is its more efficient use of the underlying hardware. ASE has only one OS process for doing the same work, thus strongly reducing overhead. In other words, ASE gets significantly more end-user performance from the same hardware than competition would, due to a fundamentally different and more efficient architecture. Open source products like MySQL and PostgreSQL cannot really be compared with ASE, as they are aimed at an entirely different class of applications. Typically, these are used in environments with no many concurrent users, no high availability or recoverability requirements, not so large database sizes, or with a predominantly read-only workload. In other words, these products are not suited for the enterprise-level computing requirements addressed by ASE. SAP ASE has always been emphasizing lower TCO, total cost of ownership, improved availability, and Microsoft SQL compatibility. That did not change after the acquisition by SAP. As for TCO, it is widely believed by DBAs with both SAP ASE and competition experience that a SAP ASE environment is significantly cheaper to operate and maintain than a comparable competition environment. Some DBAs claim that, in their experience, you need about 5 times more DBAs for some competitors than for SAP ASE. That number may be on the upper end of the scale, but it seems safe to say that you need only half of the DBAs for ASE than you do for competition. In 2008, ASE Cluster Edition reached the market. This is a flavor of ASE designed to run on clustered hardware for delivering superior high availability and advanced workload management. In 2011, in-memory capability has been added to the ASE engine to improve its performance in highly transactional environments. After the acquisition by SAP, ASE became the database of choice for non-HANA applications. So, in a nutshell, ASE is still present in 90% of top banking organizations. It is said ASE is still managing 60% of Wall Street financial transactions with partner applications like Murex or Condor Plus, capital market and dealing room management systems. ASE can really be compared to and is in direct competition with Oracle, DB2 or Microsoft SQL. It still has more than 13,000 live customers. It is part of the HANA Cloud strategy, but we will cover this in another video. SAP SQLAnywhere Server is a high-performing and embeddable relational database management system that scales from thousands of users in server environments down to desktop and mobile applications used in widely deployed zero administration environments. It offers embeddability, performance out of the box, and mobility. Let's focus on embeddability. SQLAnywhere can be easily embedded inside other applications. It combines high performance with a very small memory footprint and contains a range of features to enable self-management, self-maintenance, and self-tuning for improved performance, meaning it requires almost no database administrator. Regarding performance out of the box, SQLAnywhere is designed to deliver outstanding performance without ongoing tuning and administration. A set of automated features were included to make SQLAnywhere ideal for environments that demand high performance but have no on-site database administrator. Regarding mobility, SQLAnywhere provides enterprise-caliber databases that operate in frontline systems and devices whether connectivity with the enterprise systems is available or not. Its synchronization technologies ensure data can be exchanged efficiently over wireless and wired networks with back-end databases, application servers, and messaging systems. Ultralight, which is a subset of SAP SQLAnywhere and comes in the distribution software, is a compact relational database management system with many of the same features as SQLAnywhere, but not all of them. It can be used to create mobile databases for small footprint devices such as smartphones, handheld computers, and tablet PCs. Therefore, some features like multi-user management, privileges, data locking, and others can be removed from the source code of the database engine, dramatically reducing its footprint. Ultralight includes a built-in synchronization client that tracks changes made in the mobile databases and exchanges updates with a Mobilink server over a network to synchronize with a consolidated copy of all the mobile database instances. As a Mobilink client, Ultralight ensures that mobile applications can stay synchronized with the central database and with other Ultralight databases, and possibly can be rebuilt in case of device failure or loss. SQLAnywhere offers a wide range of options for exchanging data with existing enterprise systems and mobile devices. These data exchange technologies include synchronization, replication, messaging, and mobile web service technologies. When an application modifies shared data at any one database, the changes are propagated to the other databases in the synchronization system. Changes can be propagated by various means and through a variety of channels, allowing flexible application architecture while preserving data integrity. So, in summary, SAP ASE SQLAnywhere is a lightweight, fully featured RDBMS designed for minimal maintenance and focused on remote, mobile, and embedded usage. It features sophisticated synchronization replication to connect back to enterprise and is optimized for slower intermittent networks. SAP SQLAnywhere is ideally suited to fit the needs of IoT. If SAP ASE and SAP SQLAnywhere are primarily oriented on online transactional processing, OLTP, SAP IQ is, on the contrary, focused on decision support systems, DSS. This means a software used to support determinations, judgments, and courses of action in an organization or a business. A DSS sifts through and analyzes massive amounts of data, compiling comprehensive information that can be used to solve problems and in decision making. In short, it means it is a disk-based database engine dedicated to large-scale data warehouses, data lakes, and other big data activities. Every data in SAP IQ is part of a unified database store shared by numerous database engines. This induces a very flexible scalability, as one can add independently resources like RAM or CPU or storage. This architecture is called multiplex. It is achieved at a very low TCO in database and infrastructure administration. Our world record for data storing is about 12.1 petabytes managed by one single cluster of SAP IQ engine. Because of the parallelism introduced by multiplex, SAP IQ is capable of ingesting data at a very, very high speed. Our world record for data ingestion is of 34.3 terabytes per hour. The secret of SAP IQ resides in the combination of three characteristics: verticalization, compression, and indexes. It is very important here to remind that the slowest component of a hardware infrastructure is the disk. If SAP HANA bypasses this inconvenience by proposing an in-memory architecture, when reaching the scale of hundreds of terabytes or petabyte scale, it is difficult to argue about in-memory. The alternative is to have an engine that is designed from the beginning to minimize the access to the physical storage. We already explained the advantages of schema verticalization in episode 1 and episode 2, but it might be good to remind here that reading only what is necessary to execute a query avoids reading too much data, reducing consequently the I/O operations from the disk. Verticalization also allows SAP IQ to load the data in parallel into all the columns of a table. Compression is also a factor that will reduce the access to the storage. It is faster to read compressed data from the disk and then decompress it into the memory than read decompressed data from the disk. The gain in performance is proportional to the compression ratio of the data. With an average compression ratio of 1 to 5, this method allows a gain in performance of 1 to 5. Indices are key to the performance of a disk-based engine. The concept of an index is to allow pointing directly to the relevant data, the same way an index at the first page of a book allows you to point directly to the chapter of interest. In SAP IQ, every column is an index, and unlike a traditional database, those indexes are maintained automatically by the system. Those indexes are also compressed. It is often considered that a traditional relational database suffers from an explosion of the storage versus what is actually stored inside. A 1 terabyte database results in a multi-terabyte storage. That's even worse if you consider that traditional database request to distribute data over a large number of physical disks to allow I/O parallelism, ending with explosion factor in the range of 5 to 20 the input data volume. So, to summarize what SAP IQ is, it is a very highly scalable engine dedicated to voluminous data analysis. It is a technology that is secretly used in products like NLS, nearline storage, ILM, information lifecycle management, data intelligence, SAP data tiering in HANA, and most recently SAP HANA Cloud and Data Lake. Now that we know all about HANA, ASE, IQ and SQLAnywhere, I will see you next time in the next episode, focusing on the data movement. Thank you. Bye bye.